This is part 2 of our investigation of special right triangles. Previously we looked at 45, 45, 90 degree right triangles. We're going to wrap up this investigation with 30, 60, 90 triangles, right triangles. Okay, so the picture above shows 30, 60, 90 degree right triangles. Notice that the short leg of each of these triangles is opposite the 30 degrees, and the long leg is opposite this 60 degree angle. So I'm going to label my picture. I'm going to abbreviate SL and LL for the short leg, long leg. Okay, so the short leg, I'm going to abbreviate SL. It's the smaller leg across the 30 degrees. So short leg, short leg, short leg, short leg. Okay, long leg, I'll just abbreviate it LL. So LL. Okay, and of course the third side here is the hypotenuse. Okay, let's label a right angle in there. Okay, look for a pattern in the first 3 figures, draw figures 4 and 5. As the short leg increases by a unit, so this must be 4 and 5 down here, notice that the long leg is the short leg times root 3. So this is 4 root 3 and 5 root 3. You'll notice that the hypotenuse goes from 2, 4, 6. So this must be 8 and 10. But why? Okay, let's look at the pattern down below, organized in a table. So as the short leg increases by 1 unit, the long leg is the short leg times root 3, and the hypotenuse is, if you think about it, it's always the short leg times 2. So let's fill in a summary here. The long leg is always root 3 times longer than the short leg. And the hypotenuse is always 2 times longer than the short leg. So we base the pattern of the 30, 60, 90 triangle by first thinking about the short leg. So if the short leg is n, the long leg is n root 3, and the hypotenuse is 2n. Okay, a second way of thinking about this relationship of 30, 60, 90 degree triangles. So you have an equilateral triangle. We draw on the height and shade in one of the right triangles formed. Okay, and then label the angle measures in the other right triangle. Okay, so it's a height, obviously, that we drew, so that must be 90 degrees, because the height is perpendicular to the base. The other angles, well, we've learned previously that an equilateral triangle is equiangular, and every angle is 60 degrees. We also previously learned that the height bisects the angles, depending where you have the height. And so this angle must be half of 60, so that is 30. Okay, so there is our 30, 60, 90 degree triangle. Now, if the hypotenuse is 2x, then how long is the length of the short leg? Okay, so we have the short leg right here. Okay. Well, we've previously learned that the height of an equilateral triangle bisects the base, so the short leg must be x units long. Okay, so we have a right triangle. We know 2 sides of the right triangle, so we're going to use Pythagorean theorem to find the third side, which I have started down below. So by the Pythagorean theorem, we have x squared plus L squared, my cursive L, equals the quantity 2x quantity squared. Remember, we should use parentheses because it's 2x times 2x. Clean that up, so x squared plus L squared is 4x squared. Subtract x squared on both sides. L squared is 3x squared. We square root both sides. Remember, we can square root both the pieces separately here. So L is equal to the square root of 3 times the square root of x squared. So the square root of x squared cleans up nicely, so we get x, and we can't square root 3 nicely, so we get x root 3. So therefore, remember, L stands for the long leg. So we just proved that the long leg is equal to the short leg times root 3. And previously up here, we showed that the hypotenuse is 2 times the short leg. So keep that in mind, those ratios. They're going to help us quickly find the sides of a special right triangle, the 30, 60, 90 special right triangle. Okay, I've got 7 examples down here. I encourage you to do these examples on your own first, and then continue on with the video to see if you can do them right. I'm going to start with pictures. I think a visual helps us, but once again, you guys can do these in your head quickly, because that's the point of this, is to do it quickly and efficiently. This is a skill that you're going to need as you progress to higher level math. Okay, so I'm going to start with the first example. According to this chart, we were given the short leg, and you'll see in this chart I've given you guys various clues. I want you to go back and find the, oops, I wrote 45, 40, 90. Let's try that again, Mr. Rotor. We're going to be studying 30, 60, 90 degree right triangles. Okay, so we know the short leg is 8. Well, the rules that we had, and I'll write them up here, the long leg we discovered is equal to the short leg times root 3, and we saw that the hypotenuse is 2 times the short leg. Okay, so those patterns we saw are going to help us quickly find all the sides here. Okay, so this is 8. The long leg is short leg times root 3, so 8 root 3. The hypotenuse is 2 times the short leg, so we have 16. And of course we should label units. I'm going to forego that today for the sake of efficiency. Okay, so the hypotenuse in the second example they gave us was 22. So we got to find the sides. I think you've noticed that the short leg is kind of the foundation of all these ratios. So the hypotenuse is 22. The short leg right across the 30, okay, is 11. Maybe that'll help to label short leg here. And then the long leg, according to the pattern here, is short leg times root 3. So we're going to write 11 root 3. Okay, next example. The short leg is given to us. It's 10. So the long leg is short leg times root 3. So this must be 10 root 3 for the long leg. And the hypotenuse is double the short leg, so we get 20. And if this doesn't quite make sense numerically, you guys are always welcome to approximate just to verify your answer. That 10 root 3 is longer than 10, yet shorter than 20. Fourth example. We're given the long leg this time, so 40 root 3. Well, the long leg is short leg root 3, so it must be the case that the short leg is 40. The hypotenuse is 2 times the short leg, so therefore this must be 80. Okay, fifth example. We're given the clue that the short leg is root 3. So how do we find these? Well, the hypotenuse usually, to me, when I answer these, is the fastest to find, because all you got to do is just double the short leg. Well, double root 3 is just 2 root 3. The long leg. Well, when I have a radical for my short leg, math gets a little, kind of weird. So I'm going to use that written equation that I wrote earlier. So the long leg, remember, is the short leg times root 3. So I'm going to write root 3 times root 3, which is the square root of 9, which equals 3. Okay? So sometimes when the radical isn't in the right place, because sometimes students freak out, they're like, the long leg's supposed to have the radical. Well, it doesn't. The other side's going to have the radical. And that gives us some time that we have to kind of think about, well, what are the ratios to find the other sides? Okay? So if you always write like a statement like this, it helps you to figure out these sides when you have something weird. Okay? So we have root 3, 3 units, and 2 root 3. And you can use a calculator just to verify that these answers make sense. Okay, so this time, right across the 60 degrees, they gave us root 6. So there is our long leg. Okay? Well, what should we find next? Well, usually my rule of thumb is try to find the short leg, because that's the foundation to find the other ones using these ratios. Okay, so how do we find the short leg? Well, I know that the short leg times root 3 is equal to the long leg. So, let's see, short leg times root 3 equals root 6. Since I'm multiplying, I undo that by dividing. So the short leg is equal to the square root of 6 divided by the square root of 3. Using our rules for radicals, when I'm dividing radicals, I could always write them as a single radical. And so the short leg is equal to the square root of 2. Okay, so I get the square root of 2. To get the hypotenuse, I just double the root 2. So doubling that would give us 2 root 2. Last example. The long leg is 15. Well, once again, if I know the short leg, I could figure out everything else. So that's usually my go-to to solve for first. Okay, so I know that the short leg times root 3 is equal to the long leg. So the short leg times root 3 is equal to 15. Divide both sides by root 3. So the short leg is equal to 15 divided by the square root of 3. In a previous lesson, you learned to rationalize a denominator. Rationalize means to change it from an irrational number, root 3, and change it to a rational number. So we multiply the by root 3 over root 3. So we get the short leg equals 15 root 3 divided by, well, root 3 times root 3 is the square root of 9. Square root of 9 is 3. In a previous lesson, you saw that we can simplify the numbers outside the radical here, because we have multiplication going on in the numerator. So 15 divided by 3 is 5. So our final answer is 5 root 3. So our short leg is 5 root 3 in length. And hopefully that makes sense. If I'm taking 15, dividing by root 3, which is about 1.73, you're going to get a smaller number. Take this number, multiply by 2, because the hypotenuse is twice the length of the short leg, and so we're going to get 10 root 3.